the Z parameters of the shown T network in the figure given by. Here we can see this is a T network. It looks like T, so it is called as T network. We have to find Z parameters for this two-port network. Also we can see that there are total 4 terminals, that is 1, 1 prime, 2 and 2 prime. So 1 and 1 prime forms port 1 and 2 prime forms port 2. So it is a two-port network. We have to find its Z parameter. Solution. So Z parameter is given by, suppose this is a two-port network. This is two-port network. And there are total 4 terminals. Let's say this is 1, this is 1 prime, this is 2 and this is 2 prime. So this will be input voltage V1, this will be positive, this will be negative, and this will be output voltage V2, this will be input current I1 and this will be output current I2. Now Z parameter for this two-port network will be V1 is equal to Z11 I1 plus Z12 I2. Then V2 is equal to Z22 Z21 I1 plus Z22 I2. This is the expression for Z parameter. Now first we have to consider I2 is equal to 0. Then from this we have to find the value of Z11 and Z21. So when I2 is equal to 0, that time V1 is equal to Z11 I1 and V2 is equal to Z21 I1, and this term will be 0. So from here we can find the value of Z11. So Z11 is equal to V1 by I1. It is when I2 is equal to 0. And when I2 is equal to 0, Z21 is equal to V2 by I1. So this will be V2 divided by I1 when I2 is equal to 0. Now in case 1 we have to consider I2 is equal to 0. And in case 2 we have to consider I1 is equal to 0. So when I1 is equal to 0, that time this will be this term and this term will be 0. So V1 is equal to Z12. V1 is equal to Z12 into Z12 into I2. Then V2 is equal to, here in second expression V2 is equal to, we have to substitute I1 is equal to 0. So this will be V2 is equal to Z22 I2. V2 is equal to Z22 I2. Now from here we can find the value of Z12. So Z12 is equal to V1 by I2 when I1 is equal to 0. Also Z22 is equal to V2 by I2. V2 by I2 when I1 is equal to 0. Now here we can see this is a two-port network and this is our two-port network. Also this two-port network is linear network. So we have to solve for this network. So first again we will redraw the circuit. Now in case 1 we will consider voltage V1 and set I2 is equal to 0. So here we have to consider this voltage as V1, and here a voltage source of V1, and this will be current I1, this will be current I2, and this will be voltage V2. This will be plus, this will be minus. Now here we will apply KVL. We will apply KVL to loop 1. So if we apply KVL to mesh or loop 1. So this will be positive according to the direction of this current. This will be positive, this will be negative, this will be positive, and this will be negative. And this current will be same I1 because I2 is equal to 0. So if we apply KVL here, this will be, let's say we will start from here. So this will be minus V1, then plus 5 I1, plus 5 I1, then plus 8 I1, plus 8 I1 is equal to 0. Now here this will be minus V1 and this will be 5 plus 8 will be 13. So plus 13 I1 is equal to 0. So from here V1 is equal to 13 I1, or we can say V1 divided by I1 is equal to 13. So V1 divided by I1 is equal to 13. Here we can see V1 by I1 is Z11. So it is a Z parameter. But V1 by I1 is equal to Z11. So therefore Z11 is equal to 13. And it is a impedance. So its unit will be ohm. So this is the value of Z11. Then next is we have to find this voltage V2. So if we apply, or we can say V2 is equal to, from this mesh we can say V2 is equal to I1 into 8 or 8 into I1. 8 into I1. So this will be V2 divided by V2 by I1 is equal to 8. Also we can see V2 divided by I1 is Z21. So this will be, but V2 by I1 is equal to Z21. So therefore Z21 is equal to 8 ohm. So this is the value of Z21. Then next is, now first condition is over. Consider voltage V1 and set I2 is equal to 0. Now next condition is we will consider V2 and we will set I1 is equal to 0 or port 1 as open circuit. First we are considering port 2 as open circuit. Now we will consider port 1 as open circuit. So consider V2 voltage and set I1 is equal to 0. So here we will consider this voltage as this voltage as V2. This will be positive, this will be negative here, and this will be current I2, this will be current I1, and this voltage as V1. This will be positive and this will be negative. Now we are considering I1 is equal to 0. Now we will apply KVL to mesh number or loop number 2. So apply KVL to loop number 2 or mesh 2. So this will be positive, this will be negative. According to the direction of this current I2, this will be positive and this will be negative. So if we start from here, this will be minus V2, then plus 12 I2, then plus 8 I2, This current will be also I2 because this I1 is 0. So this current will be, the current through this 8 ohm will be only this I2. Then is equal to 0. So this will be minus V2 and this will be plus 20 I2 is equal to 0. And this will be V2 is equal to 20 I2, or we can say V2 divided by I2 is equal to 20. So V2 by I2 is equal to 20. But here we know that V2 divided by I2 is Z22. But V2 divided by I2 is equal to Z22. So therefore, Z22 is equal to 20 ohm. The unit of impedance is again ohm. Then next, here we have to find this V1. So V1 is equal to this voltage. Since it is open circuited, so the voltage across this 8 ohm will be V1. So V1 is equal to 8 into I2. V1 is equal to 8 into I2. So from here we can say that V1 divided by I2 is equal to 8. But V1 by I2 is, here we can see V1 by I2 is Z12. But V1 by I2 is Z12. So therefore Z12 is equal to 8 ohm. So this is the value of Z12. Now we have the value of all the Z parameters. So therefore Z is equal to, this is the impedance matrix, Z11, Z12, Z21 and Z22. The value of Z11 is 13 ohm. So this will be 13. The value of Z12 is 8 ohm. And the value of Z21 is again 8 ohm. So this will be 8. And the value of Z22 is 20 ohm. So this will be 20. So this is the Z parameter of that T network. What we have to find? The Z parameters of the shown T network in the figure given by. So we have to find Z parameters for this T network. So the Z parameters for this T network is this. So this is our final answer.